Hi everyone and welcome in our video demo. In this presentation we will explain an IoT platform for smart microbreweries. The IoT platform aims at making smart the process of making craft beer by providing a series of services. All services communicate with each other and exchange information to check the parameters in the different stages of production. Our platform can be seen as a communication network between the various actors involved. Now we will describe the functionalities of the main actors. The catalog represents the main register of our IoT system. It consists in a JSON file organized in user profiles, containing essential information about the MQTT broker, connected devices, access credentials, and services. The catalog program consists in two threads which work in parallel. The former is the REST service thread, which implements a REST interface allowing to external programs to get, put or delete information from the catalog through HTTP request. The latter is the device remover thread, which checks connected devices, finding no refreshed connections. If a connection hasn't been refreshed for 2 minutes, the program deletes the device from the catalog. The device connector is the communication interface which manages data exchange between physical device and external software over Internet. It implements two types of communication protocol: the HTTP protocol, exploited by a REST interface, the MQTT protocol, which allow the device to publish measures under a specific topic and receiving messages and alerts. Device connector deployment is based on specific settings contained in a JSON file, saved into the device flash memory. The Raspberry Pi device connector is organized in a multi-thread system. The connection updater thread refreshes the connection to the catalog, sending a put request to the catalog every minute. Each request contains device settings and the Unix timestamp of the request. REST service thread allows external programs to get direct measures and put settings updates. A measure sender thread is run for each device resource. It publishes measures following the senmlay data format and updates output actuator status when an alert comes. The ESP8266 is a very low-cost device, simple and adds a single core processor. For this reason, the operations are performed sequentially by a single thread.
Data analysis are carried out by control services, organized in a hierarchical structure composed of 3 levels of organization. Services are first regrouped in different service types, according to their application scopes. The second level is then represented by service units. A single unit is related to a specific device monitoring one or more resources. Resources represents the third level of service organization. Service units can perform 2 main actions: threshold comparison, which compares received measures with an internal defined threshold, publishing alerts if measures are under or above threshold, and trend monitoring, which analyzes measures and computes the trend of each resource. Services can be classified according to their operating mechanism. In single-step services, which implements threshold comparison in continuous, and in multi-step services, which consist in sequences of time-limited steps. Users and programmers can create custom-made services only modifying proper settings stored in the catalog, such as monitored resources, number of steps, threshold values, tolerances, timings, and trend monitoring activation. In order to support brewers, we have created 3 types of basic services: storage control, which is a single-step service for monitoring environmental temperature and humidity of warehouses, fermentation control, which is a single-step service for monitoring environmental temperature of fermentation rooms, and mash control, which is a multi-step service for monitoring fluid temperature in the mash tun during the mashing process. Master service is the core of data analytics phase. To achieve modularity, this program works running different threads, managing each resource of service unit in parallel. Threads update is done in continuous by the master, which obtains service information from the catalog as responses of GET requests. When a device is connected to the catalog, related unit threads are run. The resource thread performs threshold comparison and exploits the MQTT protocol to receive resource measures and send alerts. If trend estimation is needed, a specialized thread is run. If a device accidentally disconnects, all related threads will be closed.
The first step to access the dashboard is to insert username and password. After checking if the username is registered in the catalog and eventually if the password matches, the user is redirected to its dashboard. A list of connected devices is updated every 30 seconds, making a GET request to the catalog, or can be updated whenever the user wants by clicking on the refresh button. The list shows the device IDs and their location. A device is selected by clicking on it. In a second tab, the user can see the device currently selected, choose the resource of interest, get the current thresholds and timings, or set new values for them. A donut gauge shows the real-time measurements for the selected resource, obtained through an MQTT subscription. Historic measurements are saved and visualized on an history line chart. Alerts when the measurements are under or above the desired thresholds are received from the master service, making an MQTT subscription to the proper topic. In the same way, the dashboard receives and shows information about the trend that the measurements are following and the time that is needed to reach the next threshold. After a welcome message, also in case of the Telegram bot, the user is asked to insert username and password to access the system. At this point, the user can select the process for which he wants to see the connected devices. After selecting the device of interest from the list, a menu with all the possible interaction with the device is sent by the bot. The user can get the current measurements through GET requests to the REST API of the device connector for all the resources that are currently active in the device, or get the thresholds and timings for all the resources of the selected device from the REST API of the catalog. Moreover, it is possible to modify the thresholds and timings. The bot first of all asks what is the resource for which the user wants to set new thresholds or timings. Then, if it is a multi-step resource, the user has to select the step to modify. At this point, the user can insert a new numeric value. Finally, an output message shows the result of the operation. Using the commands of the bot, it is possible to enter or exit a special mode in which the bot only handles the alerts. When the bot is operating in these states, it is not possible to use the other functionalities until the command to exit the alert mode is sent. Alexa, run BREWon.
Welcome to BREWon. What would you like to know?
Help me.
You can get information about measurements and thresholds for a specific device, asking a question like, get current temperature in DHT11A. I can also provide the list of the currently connected devices in the whole system or in a specific control process. What would you like to do?
Which devices are connected in fermentation?
Here is the list of connected devices in fermentation, ESP_1.
What is the humidity measured by ESP1?
Measured humidity in ESP_1 is 71.2%.
What are the temperature thresholds of ESP1?
Temperature threshold for ESP_1 is 21 Cel.
Goodbye.
Thank you for using BREWon. See you soon.
The Big Brother is the main manager program installed on the user PC and represents an interaction interface between the end user and the IT system. It consists in a command line interface that allows user to log in with proper credentials or create a new profile. Logged user can choose among different managing actions. Each of them is performed sending put request to the catalog or device connector. One option is the MQTT broker configuration, which must be validated by the system. The second option is to edit device settings, possible only if the device has no services associated. Control services can be edited, added or removed selecting the third option.